Hello everyone! Today we are going to share about decoupling capacitor analysis. When designing certain chips, there are resistors and capacitors around the chip, including decoupling capacitors. Adding or removing decoupling capacitors mid-project often leads to costly PCB design reworks, because any single modification in PCB design will affect many other elements. The new decoupling capacitor analysis feature allows you to analyze decoupling capacitors for chips at the schematic stage. After the analysis is completed, you can determine the approximate distance between decoupling capacitors and power pins. This distance can also be converted into the capacitor effective areas in PCB design, which greatly improves PCB design efficiency and quality. Now let's demonstrate the specific operation steps. First, select the target device in the schematic interface and run the capacitor analysis. Click the chip icon in the upper left corner, which allows you to quickly select capacitors from the component library. In this interface, you can filter values and add capacitors. We will add 6 8-ohm, 1 UF and 10 UF components to the component box respectively. Power symbol is used to specify the network connected to the decoupling capacitors. Connections is used to define the correspondence between capacitor pins and networks, ensuring that capacitors are correctly connected to power or ground. This is the reference designator start value. Distance is used to uniformly set the placement position of decoupling capacitors to avoid messy manual placement. Here 10 million Israeli new shekels means that capacitors will be automatically placed mils away from the chip's power pins, ensuring neat schematic layout and the shortest routing. Parent is used to specify the target chip to which decoupling capacitors need to be added. The tool will automatically identify the chip's pins and add decoupling capacitors in batches. Target impedance analysis is the simulation verification part of decoupling design. You can keep the default values. Click Plot Impedance Profile to generate the impedance frequency curve of the power network to verify the decoupling effect. The red line represents the target impedance value, and the green line represents the actual impedance curve. The impedance curve will vary in different frequency ranges. We can adjust the number of capacitors, change the quantity of 6 8-ohm and 1 UF to 10 each, and generate the impedance frequency curve again. You can see that the actual curve shifts downward. You can also adjust the capacitor placement distance to increase the difference, and you'll see a significant change in the curve. Through repeated adjustments, we can find the optimal placement distance for capacitors, avoiding under-design or over-design, and achieving a perfectly balanced design. After the adjustment is completed, click OK to place the components. That's all for today's sharing. Thank you everyone.